In 2010, a team of psychologists at the University of Wisconsin-Madison ran an experiment. They asked volunteers to take a concentration test while overhearing a conversation. Some heard the full exchange, others heard only one side. The result was stark. The halfalogue listeners scored significantly worse. Their brains, it seemed, were working overtime trying to fill in the missing pieces. This wasn't a matter of rudeness or willpower. It was a cognitive trap. The question is, why does hearing only half a conversation drain your brain more than a full one? The effect has a name, the halfalogue effect. It was coined by psychologist Veronica Galvin and colleagues in a series of studies. The core idea is simple. Every time you hear someone speak, your brain automatically predicts what comes next. When you hear "I'm going to the," your mind races through likely continuations: store, bank, doctor, gym. In a full conversation, the response confirms or corrects your prediction. The loop closes. But in a halfalogue, that confirmation never comes. The prediction stays open, unresolved, demanding attention. Your brain keeps searching for closure. And that searching consumes mental resources you could be using to focus on your own work. This isn't just speculation. Neuroimaging studies back it up. When people listen to halfalogues, areas of the brain involved in language prediction and reward processing show unusual activity. The anterior cingulate cortex, which helps monitor conflict and error, stays unusually active. The brain is treating the missing half as a problem to be solved. It keeps trying to complete the pattern. And because the pattern never completes, the brain never gets to relax. It's like a musical chord that never resolves. The tension lingers. You can't help but wait for the final note. The mechanism goes deeper. Working memory is the bottleneck. When you hear a partial utterance, you have to hold it in memory while generating possible completions. That uses up limited slots. Meanwhile, you're also trying to process any new utterances from the halfalogue speaker. Each new fragment reopens the loop. Compare that to a full conversation. You hear a question, then an answer. Both sides give you context and closure. Your brain can chunk the exchange into a single event and move on. With a halfalogue, every sentence is a loose end. The cognitive load is cumulative. By the end of a 3-minute call, your ability to focus on anything else has measurably degraded. But there are limits to the effect. What if the halfalogue is in a language you don't understand? Then you can't predict anything. The sounds become like random noise, no more distracting than a passing car. Studies show that bilingual listeners are less distracted by halfalogues in their non-native language. The brain's predictive machinery only works when it has a model. Similarly, if you know the topic of the call, the effect weakens. If you overhear someone say, "The meeting was rescheduled to," and you already know the context, your brain can narrow the possibilities drastically. The prediction becomes easy. The itch is easier to scratch. So the halfalogue effect is not universal. It depends on your ability and motivation to predict. Real-world implications are everywhere. Open offices are filled with halfalogues. Someone at the next desk takes a cell phone call and suddenly productivity drops across the floor. It's why libraries and quiet train carriages ban phone calls. It's not just the volume, it's the content. A full conversation between two people at a table, speaking at the same volume, is far less disruptive. The brain can habituate to a steady hum of dialogue. But a halfalogue is an unpredictable stream of incomplete events. Each sentence is a fresh intrusion. Architects and workplace designers now consider this when planning layouts. Some companies have installed phone booths specifically to contain halfalogues. The cost of distraction is real. There is also an evolutionary angle. Our brains evolved to monitor our social environment for threats and opportunities. A halfalogue signals that someone is communicating with a third party, and we are not included. That ancient vigilance system kicks in. Are they talking about us? Is there news we need to know? The brain treats the missing half as a signal that we are missing information, and missing information can be dangerous. This is why halfalogues feel more urgent than full conversations. Your brain is not just filling in words. It is trying to assess social relevance. That is a deeper, more ancient computation. The effect extends beyond phone calls. Any incomplete sensory input that your brain tries to predict can cause similar cognitive load. Think of hearing a song you know, but it cuts off before the final note, or reading a sentence that ends mid-word. The brain's prediction loop is general. It applies to speech, music, visual sequences, even touch. But speech is uniquely powerful because it conveys social meaning. We are hardwired to care what others are saying. Halfalogues hijack that system. A counter case worth considering: what if the halfalogue is from a familiar voice, a partner or close friend? Does the effect get stronger or weaker? Research suggests it gets stronger. Familiar voices have more predictable patterns. Your brain generates more specific predictions. When those predictions fail to confirm, the mismatch is larger. The cognitive load increases. So your partner's phone call in the next room is actually more distracting than a stranger's. The brain invests more in the prediction. The unresolved loop is more salient. Now consider a second line of evidence from a 2018 study by researchers at the University of London. They measured heart rate variability in people exposed to halfalogues. Heart rate variability is a marker of mental effort. The results: halfalogues caused a significant increase in cognitive load, more than full conversations or silence. The participants also reported higher levels of irritation. The physical response matched the subjective experience. Your body knows you are working harder, even if you don't consciously realize it. This has practical implications for multitasking. You are not just annoyed by halfalogues, your performance actually drops. In one experiment, people solving word puzzles made 30% more errors when a halfalogue played in the background compared to a full conversation. That is a measurable deficit. And because the distraction is involuntary, you cannot simply try harder to ignore it. Your brain's predictive machinery is automatic. It runs whether you want it to or not. The only solution is physical removal or acoustic masking. Some researchers have proposed that the halfalogue effect is a form of cognitive interference similar to the Stroop effect. In the Stroop effect, the automatic process of reading interferes with naming the color of a word. In the halfalogue effect, the automatic process of predicting speech interferes with maintaining focus. Both are examples of the brain's default operations conflicting with a task. The halfalogue effect is not a flaw. It is a byproduct of a powerful feature. The same prediction machinery that lets you understand rapid speech also makes you vulnerable to this specific kind of distraction. There is a limit to how much your brain can compensate. If you have a high working memory capacity, you may handle halfalogues better, but the effect still exists. Even expert meditators show measurable distraction. The neural circuitry is too basic to override entirely. The best you can do is habituate. After 10 minutes of a halfalogue, your brain may start to build a model of the speaker's patterns, reducing the surprise. But that itself takes time and cognitive resources. In the short term, the damage is done. So where does this leave us? The halfalogue effect is a lens into how your brain processes the world. It reveals that your mind is not a passive receiver of sound. It is an active predictor, constantly generating expectations and feeling unsettled when they are not met. A phone call is not just noise. It is a pattern with a missing piece. And your brain will spend energy trying to find that piece, even when you know it is none of your business. That is the cost of having a brain that is always one step ahead. The next time you find yourself straining to hear the other end of a phone conversation, remember, your brain is not being nosy. It is just trying to finish a sentence it never heard. And that unfinished sentence, unresolved prediction, that cognitive itch, is exactly why halfalogues are so uniquely draining. The brain is a prediction machine, and predictions hate to be left hanging.